For this question, I decided to tackle it, explore it a little bit. It was making me think. So, for any one question, there's 6 possible answers. That's the probability of me guessing correctly, 1 out of 6, and guessing incorrectly, 5 out of 6. And then this was a very specific pattern. I mean, what if I get the first 2 wrong and the last one right? So I said, well, is this a binomial distribution? I'm not sure. So I decided to tackle it this way. So the probability of me guessing and getting the first question correct is 1/6 right, 5/6 wrong. For the next question, 1 out of 6 and 5 out of 6. For the down here, if I guessed wrong on the first one, 1 out of 6, 5 out of 6. And then on the next one, this is my last question, 1 out of 6, 5 out of 6. Again, 1 out of 6, 5 out of 6. And again, 1 out of 6, 5 out of 6. And then lastly, 1 out of 6, 5 out of 6. So if I think about what they're asking me to do, I'm going to get it wrong, I'll get the next one wrong, and then I'll get the last one correct. So I'm going to multiply 5, 6, because that's the wrong path. There's another wrong one, and then I want to go to the right. So really what I'm doing is I'm doing 5 out of 6 squared, or 5 out of 6 times 5 out of 6 times 1 out of 6, or 5 out of 6 squared times 1 out of 6. And when I did this on my calculator, I got that number, and that was correct. So that's the first part. So for the second part of this problem, I thought that maybe I'd tackle it the same way. So what I did was, let me get a pointer going here. So I looked at my tree diagram that I made again, and this path here is getting all 3 correct. This path here, I got the first 2 correct, then 1 wrong, so that's 2 correct. This path here is 1 right, 1 wrong, 1 right, so that's 2 correct. This path here is 1 correct, 1 wrong, another 1 wrong, so that's only getting one question correct. Then I'm coming down here, so it's a wrong question, a right question, a right question, 2 correct. A wrong, a right, a wrong, so that's what I'm looking for. That's a success. And then 2 wrong, and a correct. So what I'm seeing is 3 correct paths, or 3 paths that give me what I want, 1 correct answer. So I'm only looking at for getting 1 correct answer. So isn't that the same thing as saying 1 out of 6 times 5 out of 6 squared times 3? So that's exactly what I did, and that's how I came up with that answer. And then I got to thinking, well, all these other questions right around this are about binomial probabilities. So could I have used that binomial probability calculator? So then I looked at this and I said, well, let's see. The probability from question to question state of guessing correctly is 1 out of 6. I'm running 3 questions, so that's a fixed number of trials. Get the question from question to question is independent, and the probability of guessing correct doesn't change. So this is a binomial experiment. So what I did is I fired up that online calculator. There's a probability 1 out of 6 is about that decimal. It's rounded. And then 3 trials, 1 success, because I want to know the probability of just getting 1 right. And look at that. That's the exact same answer. So if you can recognize a binomial distribution, it certainly saves you some steps, though it's good to reason it out and think about it. So hopefully that'll help you get that answer right. You should be able to just jump into this knowing that I showed you this. Now the tricky part will be being able to apply it when you don't know that's exactly what's happening here. So try some of those exercises out of the textbook.